Good morning, everybody. Today we are going to start talking about the first concept in stoichiometry, um, which is called the mole ratio. So first off, just want everyone to stay calm. Stoichiometry is this big, giant word, stoichiometry, that sounds so imposing and difficult, but really, keep calm. It is easy. We've covered all this before. So stoichiometry is really the relationship between the relative quantities of substances used or produced in a chemical reaction. So stoichiometry involves math that we've already done. Dimensional analysis, balancing equations. The only thing we're doing is we are adding a concept called mole ratio. So let's get into mole ratio. So really, mole ratio is just the ratio of one component to another component in a chemical reaction. And we're going to see, as we're going to see in just a minute, the coefficients in the chemical reaction help to determine mole ratios. So let's look at this this one example. So we have two sodiums. Two sodiums react with one chlorine to produce two sodium chlorides. So in a single reaction, how many molecules would be consumed or produced of sodium for a single reaction? Well, based on this, we would see two being used. In a single reaction, then we'd also see that one chlorine would be consumed, one Cl2, and from that, based on this balanced equation, we'd produce two sodium chlorides. So if we look at that ratio, it's really 2 to 1 to 2. Simple enough. So what if this reaction happened 100 times? Well, we'd see 200 sodiums being consumed, 100 chlorine molecules being consumed, and finally producing 200 sodium chlorides. Well, okay, same ratio, 2 to 1 to 2. Again, and now if we had this reaction happen 528 times, we would see the same kind of concept, same basic ratio. We'd have 1,056 sodium consumed, 528 chlorines, and 1,056 sodium chlorides produced. Again, that same 2 to 1 to 2 ratio. So let's flip this on its head and look at this. If we had this happen 6.02 times 10 to the 23rd times, even more. Well, we think about this. We're going to produce 1.204 times 10 to the 24th, are going to consume that many sodiums. And we would consume 6.02 times 10 to the 23rd chlorines, and again, the same 1.204 times 10 to the 24th sodium chlorides would be produced. But still that same 2 to 1 to 2 ratio. If we think about this in moles, remember a mole is 6.02 times 10 to the 23rd molecules. We're seeing 2 to 1 to 2. The same numbers that we are seeing in our coefficients. So ratio is really determined by the coefficients in that balanced equation. So if we are looking at our sodium plus chlorine gives us sodium chloride, ratio of sodium to chlorine is 2 to 1. Ratio of sodium to sodium chloride is 2 to 2, and the ratio of chlorine to sodium chloride is 1 to 2. So how do we use that? If we go, to this, if we think about the same thing, we have our sodium plus chlorine gives us NaCl. If you have 10 moles of sodium, then you'll use 5 moles of chlorine. So how do I show that? So if I'm starting with 10 moles Na, and as we get into stoichiometry, I'm going to make a very big suggestion, because this really does help, is if you start writing not just the units moles, but also moles of what you are looking at, like in this case, moles of Na. Okay, we're just doing dimensional analysis here. We're doing a unit conversion. All right, if I have moles of Na on top, I'm going to put moles of Na on the bottom, and moles, since we are trying to go to chlorine here, moles of Cl2 on top. Okay, so if we are looking at our ratio, 2 to 1, we have 1, we just put the coefficients really in front of each. So 1 mole of chlorine, 2 moles of sodium. Okay, 10 times 1 divided by 2 gives me 5 moles of chlorine. And if we double check this, we can see that our moles of Na are canceling each other out, leaving us with just moles of Cl2. So we do the same thing. Let's take our 10 moles of Na. Now we're going to go to sodium chloride. So moles of NaCl on top, moles Na on the bottom. Again, take those, take the coefficients, and we're just going to put 2 over 2. 2 over 2 is really 1, so 10 times 2 divided by 2 gives me 10 moles of NaCl. Again, our moles of sodium cancel out. It'd be the same thing if I said, hey, you produce 10 moles of sodium chloride in this in this reaction. How much chlorine did you use? So we would be then starting with 10 moles of NaCl. And if we are trying to get to moles chlorine, we know we're going to have moles NaCl on the bottom, moles chlorine on top, because we want our chlorine to be on top. We want we want these to cancel out. We have 1 mole of chlorine, because that's what's in our coefficient, 2 moles of NaCl. We get these to cancel out, leaving us with moles chlorine. 10 times 1 divided by 2 gives me 5 moles of chlorine. In this case would be used versus produced. So that's it. That's as simple as this is really, it's not a super hard concept. It's just another conversion factor that we're going to utilize as we look at a chemical reaction and say, we start with so many moles of one component. How many moles of the other components would we be using or producing? So that's it. I hope this helps. And we will continue on and move to to slightly more challenging aspects of stoichiometry in the coming days. Thanks so much. Talk to you soon.